Hello everyone, so in today's video we are going to be using everyone's favourite tea time tipple, the Gin and Tonic, to explain the pigeonhole principle. Now, the pigeonhole principle is a mathematical theorem that mainly has uses in the field of combinatorics. So before we can get straight into the pigeonhole principle, the first thing that we need to understand is the concept of the natural numbers. Now, the natural numbers are the counting numbers, so 1, 2, 3, and so on. We can use the letter n to denote an arbitrary value for these natural numbers, and we will use this in the theorem. Now that we understand this, we can state the pigeonhole principle in its most simple form. If we let n denote an arbitrary natural number, the theorem states that if n plus 1 pigeons are placed into n pigeonholes, then some pigeonhole must contain at least 2 pigeons. If we now consider the specific case when n is equal to 2, then our theorem becomes if 3 pigeons are placed into 2 pigeonholes, then some pigeonhole must contain at least 2 pigeons. So now let's try to visualise this example using gin and tonics. If we have 3 limes representing our 3 pigeons and 2 gin and tonics representing our 2 pigeonholes, and we want to place our limes into the gin and tonics, then by the pigeonhole principle, some gin and tonic will contain at least 2 limes. So to see why this works, let's look at the possible ways of distributing the limes amongst the drinks. So let's consider the first case. The first case is that all 3 limes go into one glass, as such. Now the second way of placing the 3 limes into the 2 glasses is to have 2 in the first glass and 1 in the second. But observe that in both of the cases that we have demonstrated, then at least one glass contains 2 limes, as was stated in the pigeonhole principle. So now that we understand the pigeonhole principle in its most simple form, we can move on to consider the general pigeonhole principle. So if we let n and k denote 2 natural numbers, the general pigeonhole principle states that if n pigeons are placed into k pigeonholes, then some pigeonhole must contain the ceiling of n over k pigeons. Notice that in the general pigeonhole principle we have introduced the concept of the ceiling function. Now in this context we are considering the ceiling of n over k. This is just referring to the smallest integer that is greater than or equal to n divided by k. So now let's consider an example. If we let n equal 5 and k equal 2, then the general pigeonhole principle would state if 5 pigeons are placed into 2 pigeonholes, then some pigeonhole must contain at least the ceiling of 5 over 2 pigeons. If we try and explain this now using our example of gin and tonics, we have 5 limes representing our pigeons and 2 gin and tonics representing our pigeonholes. Then by the pigeonhole principle, some gin and tonic must contain the ceiling of at least 5 over 2 limes. So now let's think about what the ceiling of 5 over 2 would be. Well, 5 over 2 is equal to 2.5, and the smallest integer that is greater than or equal to 2.5 is equal to 3. So what our pigeonhole principle is actually stating in the context of gin and tonics is that if 5 limes are placed into 2 gin and tonics, then some gin and tonic must contain at least 3 limes. So now let's demonstrate this by actually placing our 5 limes into our 2 gin and tonics. Notice that there are 3 separate ways that we could do this. The first of these is having all 5 limes in one glass, as such. The second of these is having 4 limes in one glass and 1 in the other. And finally, having 2 limes in one glass and 3 in the other, like so. Notice that in all 3 of these possible cases, then at least one glass contained at least 3 limes, again demonstrating our theorem. The same logic can be applied to an infinite number of examples, so no matter how many drinks you are having or how many limes you've got, the pigeonhole principle will always state the same. So let's recap the general pigeonhole principle. Let's let n and k be natural numbers. If we want to place n pigeons into k pigeonholes, then some pigeonhole must contain the ceiling of n over k pigeons. If you enjoyed today's video, don't forget to subscribe to our channel. You can also click the link below to download a worksheet. This will help you to test your understanding and help you to improve. And remember kids, don't drink and derive.